Hello everyone, today I'm going to be talking about the iOS Apple's mobile operating system. Today we're going to go through a little introduction, an overview of the iOS, architecture and design, key features and core components, file management and device management, security and privacy features, user interface design, and we're also going to go through a comparison with other operating systems, advantages and limitations, future development and updates, conclusion and references. For the introduction, the iOS is Apple's mobile operating system designed for its range of mobile devices, including the iPhone, iPad, and iPod Touch. First introduced in 2007, iOS has become the second most popular mobile operating system worldwide, following Android. About the overview, as I said, the iOS operating system was first released in the year 2007 for the first generation iPhone. Now, it also supports many Apple devices such as iPod Touch, iPad, and Apple TV. It has now become a mobile operating system for Apple's portable devices. iOS is based on the Macintosh OS X and supports the programming languages Swift, C, C++, and Objective-C. iOS provides a multi-touch interface to use the iOS device. About the architecture, we have four main layers: Core OS layer, Core Services layer, Media layer, and the Cocoa Touch layer. So for the Core OS, it manages low-level features such as memory management and hardware interaction. For the Core Services, it provides essential services like networking and file access. About the media layer, it handles audio, video, and graphic capabilities. And lastly, for the Cocoa Touch layer, is the one that most developers will interact with directly. About the key features, we have the user interface, which includes multi-touch gestures like swipe, tap, and pinch. For the security, it has high-level security features, including encryption and sandboxing. And for the app ecosystem, it has access to millions of apps via the Apple App Store. And lastly, for the integration, it has seamless integration with other Apple products like Macs and Apple Watches. Now for the key components, first we have CPU management. iOS utilizes the XNU kernel, which is responsible for CPU scheduling and management. The mesh component of the kernel handles processor resources, including CPU usage. It manages task scheduling, ensuring efficient use of the device's processing power across various applications and system processes. Now for the memory management, memory management in iOS is also handled by the mesh component of the kernel. It provides memory protection and manages the allocation and delocation of memory resources. iOS uses advanced memory management techniques to optimize performance and battery life, including automatic reference counting for efficient memory allocation and delocation. Now for networking capabilities are provided through various frameworks in the Core OS and Core Services layer. The system configuration framework in the Core OS, as I said, allows application to communicate with and connect to nearby networks. Higher level networking APIs are available in the Core Services layer, enabling developers to implement features like cloud synchronization and social media integration. Now about the file system and device management. For the file system, iOS uses a file system that is largely hidden from users, focusing instead on app-based data management. Each app operates within its own sandbox and to enhance security and privacy. It is managed at the Core OS layer. iOS uses a sandbox file system approach, where each application operates within its own isolated environment for enhanced security. The Core Services layer provides higher level APIs for file management, such as the Core Data Framework, which offers data management services for iOS applications. And about this device management, while device management encompasses various aspects of the hardware interaction and system configuration, in the Core OS layer which contains components for managing external accessories and Bluetooth connections. It also includes security services and local authorization frameworks to manage device access and permission. The core services layer provides additional device management capabilities through frameworks like Core Location and Core Motion, which handles location services and motion-based data respectively. These core components work together to provide a secure, efficient, and responsive operating system for iOS devices. The layered architecture of iOS ensures that higher level services and applications can interact with these core components through well-defined interfaces, maintaining system stability and security. Talking about security and privacy, security is a key focus of iOS, with a range of features designed to protect users' data and privacy. These include encryption and sandboxing and a range of permissions that control how apps can access user data. Understanding these features is important for both users and developers. For users, they provide reassurance that their data is being handled securely. For developers, they provide guidelines on how to handle data responsibly and build trust with users. Now for the user interface, the UI designed for iOS is centered around direct manipulation using multi-touch gestures. It emphasizes simplicity and ease of use, which focus on providing a consistent experience across all Apple services. Now let's compare the iOS and Android. Compared to Android, iOS offers a more controlled environment with stringent app review processes, resulting in a more secure but less flexible platform. Android, on the other hand, provides more customization options, but it used across various manufacturers' devices. About the advantages and limitations. For advantages, we have high security standards, seamless integration with Apple ecosystem, intuitive user interface, and for limitations, limited customization compared to Android. Closed ecosystem restricts capability with non-Apple devices. About the future developments, Apple releases major updates to iOS annually, introducing new features and enhancements. The latest version is iOS 18, includes improvements in AI capabilities and user interface refinements. To conclude, iOS remains a leading mobile operating system due to its focus on security, user experiences, and seamless integration within the Apple ecosystem. Its continuous evolution ensures it stays competitive in the rapidly changing tech landscape. These are the references used, and thank you for your time and attention.